Today, let's go over a medium question that I solved by myself just 5 minutes ago. This one I struggled with for a long time, but I finally solved it, and I'm pretty happy about that. So, you're given an integer array, a list of integers, and a target value in which they want you to find the particular number that, when you add up all the numbers together, closest to the target in the absolute difference. And if there's a tie, you return that minimum integer. And notice that the answer is not a number from ARR. That's fine. For example, in this case, you would try 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you would find that 3 is the closest because absolute value of 9 minus 10 is 1. And there's nothing that can make 10 exactly. Unlike here where 2, 3, and 5 itself makes 10. Or because 10 can't be divisible by 3. And so, so they just want you to find the closest value in terms of the number that caused, when sums together, to closest to target. And so one of the edge cases here is that you actually cannot change a number. So for example, if you're trying 1, 2, 3, 4, 5, 6, 7, 8, 9, if you're trying 3, here the total sum would be 233 instead of 333, because any number that's smaller than the current one you're trying, you cannot actually add that to the sum. You just use the original number. So with that being said, now we can get started. And just to get some examples here, we can try for 1. That would be 1, 1, 1. So the sum would be 3. What is the absolute difference of 3 minus 10? That's 7. And same with 2. We can try 2, 2, 2. That's going to be 6. Absolute difference of 6 minus 10 is 4. So that's a little better. That's closer. And we just keep doing this until we get to the maximum number. So you can do this using a brute force approach, but you can also do this using binary search. The idea here is that we're going to make decisions to throw away either half of the array based on what the difference is currently. So for example, if you have an absolute difference that's bigger than the target, or if you have an absolute difference that's closer to the target, but the sum is bigger than the target, then you have to decrease it. If the absolute difference is closer, but the sum is less than the target, you have to increase it because you're trying to get closer to the target, right? And the thing that controls that is your current number that you're using to sum up as much as possible. So with that being said, let's declare a left and a right pointer so we don't have to iterate and try every single number. So now let's say left is less than right. Standard stuff. Use our mid to... This is a number we're going to try. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now let's call this current as a list. And actually, let's create a dictionary while we're at it, because we want to store the minimum such integer, because there's going to be multiple options to choose from at the end based on for this. So for example, the key in the dictionary is going to be the actual number itself, and then the value is going to be the differences. And so we're going to find the smallest number itself. Actually, the difference is going to be the value, and the number is going to be the value in the dictionary. We're going to find the smallest value. So let's call this current, and now we can iterate over ARR. So as we said, if the mid is bigger than or equal to A, then we can append mid. If, for example, here we're having 2, it's too small, then we're just going to append A instead. So if A is less than or equal to mid. Sorry, this is supposed to be backwards. If mid is bigger than or equal to A, then append mid. If mid is less than or equal to A, then you can append A. Let's print current to C. Let's just do this for now. $595. Looks like that's not correct. So 595, we're supposed to get, well, let's print mid first to C. So 5 is 595. Nope, it's the other way around. It's supposed to be 555. So if A is less than or less than mid, then we append A, else then append mid. I want to get this to be 233 for an iteration. Good. So for 3, 233 instead of 333, because 2 is smaller than the current number we're trying, which is mid. And now we can call this current sum equals to sum of currents. Based on this, we can make a couple decisions. So first of all, we have to get the difference, which is going to be the absolute difference of your current sum minus the target. So let's print the difference to see. Okay, this is going to be infinite loop. So the difference is going to be, well, let's print this mid and the difference just to show you. So if the mid is 3, the difference 2 plus 3 plus 3 is 8. 8 minus 10, absolute value is 2. 4 plus 4 plus 4, in this case, is only 2 plus 3 plus 4 because these are smaller than 4. So 2 plus 3 plus 4 is 9. 9 minus 10, absolute value is 1. So now that we have the difference, we first need to insert it into the dictionary because we want to find the smallest possible result that causes this. So let's say dmid.append difference, right? Because so the mid is going to be, so what are we choosing here? We're choosing the actual number itself that causes it. Okay. So then, yeah, dmid.append difference. And then now we can ask a couple questions. So if the mid or the sum, if current sum, or sorry, if the difference is less than our historical, because let's create historical. This is just going to measure how far we are from the target in terms of difference. So if the difference is less than our historical value, then that's great. So we can update historical to be difference. But we also have to ask if the difference or if the current sum is less than the target. If it is, then you want to get closer to it in either direction. So if difference less than or equal to historical, if the difference is too big, then we still have to ask this question, right? Regardless of whether we do that or not, this is just the differences. We're going to update historical to be difference. And then at the end, let's print D to C. So got this backwards. Where is it? Difference.append mid. Because we want the smallest mid value that caused this. And then now we can, so 1 is the smallest difference, 3 is the smallest difference out of the ones. The number 3 is the smallest possible causer. Okay, so this is strange. Okay, let's see. Less than or equal to, or we're missing results. Okay, so 0 is the smallest difference because 2 plus 3 plus 5 is 10, which is 10, so the absolute difference is 0. Then the smallest causer of that is 5. So now we can just say answer equals to, well, it's minimum cause equals to float of infinity. And then here we can say minimum cause equals to min of minimum cause and mid, right? Because we want to find the 0, or here we want to find 1. And then the answer is just going to be the minimum of D minimum cause. Because D minimum cause is going to map to this list, and then the minimum of that is 3. D of minimum cause is going to map to this list. The smallest of that is 5. D minimum cause is going to map to 2, which the smallest of that list, corresponding list, is 11361. And then we can just return answer. So I guess if not, so d minimum cos, let's print answer to C. There's okay, what is minimum cos? Minimum cos. Minimum cos is 2? No, minimum cos is supposed to be 1. Okay. Minimum cos, yep. Is it the mid or is it the difference? Might be the difference, right? Okay, yeah, it was a difference because we want to find the minimum difference, not the minimum. Well, the job of this list is to find the minimum of whatever number caused it, but first we want to find the key, which is going to be the smallest difference we can ever find doing all these sums and comparing them to target. And then now we can just return minimum of answer because that's the list. Oh, okay. So one test case, I don't know why that happened. Maybe less than or equal to. Strange. So left is 0. There we go. Yep. Some edge cases there, but yeah, it's a tough one, but if you understand the concept, I think it's not that bad. So yeah, thank you for watching this video and hope this is helpful and stay tuned for more.